Today we will discuss about dyeing and its types. Dyeing is the application of dyes or pigments on textile materials such as fibers, yarns, and fabrics with the goal of achieving color with desired color fastness. Dyeing is normally done in a special solution containing dyes and particular chemical material. Dye molecules are fixed to the fiber by absorption, diffusion, or bonding, with temperature and time being key controlling factors. The bond between dye molecule and fiber may be strong or weak, depending on the dye used. Dyeing and printing are different applications. In printing, color is applied to a localized area with desired patterns. In dyeing, it is applied to the entire textile. The primary source of dye, historically, has been nature, with the dyes being extracted from animals or plants. Since the mid-19th century, however, humans have produced artificial dyes to achieve a broader range of colors and to render the dyes more stable to washing and general use. Different classes of dyes are used for different types of fiber and at different stages of the textile production process, from loose fibers through yarn and cloth to complete garments. Acrylic fibers are dyed with basic dyes, while nylon and protein fibers such as wool and silk are dyed with acid dyes, and polyester yarn is dyed with dispersed dyes. Cotton is dyed with a range of dye types, including vat dyes, and modern synthetic reactive and direct dyes. Dope dyeing. In dope dyeing, pigments are added to the polymer solution itself before extruding the fibers. The process provides the dyed fibers with excellent fastness properties. The dope dyeing applies to synthetic fiber only. This method of dyeing is also known as solution dyeing, TEN, and mass coloration, or mass colored. It has limited color options. Fiber dyeing. In fiber dyeing, the dyeing takes place at the fiber stage before they are spun into yarn. It is also called stock dyeing. Examples are mélanges and medleys. Yarn dyeing. In yarn dyeing, the yarns are dyed first before the fabric manufacturing stage. The yarn dyeing happens in hanks or in package dyeing. Package dyeing is a method where yarns are wound on perforated cones placed in a dye vessel. The dye solution is then alternatively pushed inside out and vice versa. Examples are many stripes, patterned, checks, and jacquard designed fabrics. Piece dyeing. In piece dyeing, the dyeing takes place after producing fabrics with undyed yarns. Most of the solid dyed fabrics are dyed with the piece dyeing method, and the materials are also called piece dyed. Garment dyeing. In garment dyeing, the garments are constructed of undyed, but ready for dyeing, fabrics. Different types of dyeing machines. This is perhaps the most interesting part of the discussion. There are various types of machines along with separate features and suitability. Let us have a closer look. 1. Jet dyeing machine. Here the two ends of a fabric are stitched together, thus forming a huge roll or chain-like continuity. The fabric in this form is then put inside a closed chamber through which water with dyes and chemicals dissolved moved fast in the form of jets. The pressure of the jet makes the fabric move slowly inside the chamber, helping to achieve uniformity. Since the fabric is not under much tension, this kind of dyeing machine suits almost all kinds of fabrics. Being inside a closed chamber, it is also possible to increase the pressure of air inside, thereby enabling temperatures above boiling point of water to be achieved. As a result, synthetic fibers like polyester and nylon that need temperatures above glass transition for dyeing can be treated in this machine. It is a batch machine, thereby having limitation in the volume or amount of fabric that it can dye at a time. Though, jigger dyeing machine. In jigger, the fabric is rolled onto a roller, and its leading edge is passed through a few guide rolls into a bath of water containing dyes and other accessory chemicals. This leading edge is further passed onto another roller on the other side of the bath or tumbler. When the dyeing starts, the fabric is unrolled from one roll and rolled onto the other. Once a full passage is completed, it is passed on reversibly from the second roll to the first, ensuring that it passes through the bath of color as it was in the first case. The number of such passage depends on the depth of shade that is to be achieved. Here, there are two visible disadvantages. One is that the fabric is pulled from one roll to another, thereby making it obvious that very fine, thin and weak fabrics may not be suitable for the process. Also, it is an open machine so that we cannot increase the pressure and hence the dyeing temperature above the boiling point of water. This restricts us from dyeing synthetic fibers in this process. Another minor thing to note here is that the liquor does not circulate in this case, and hence, there can be issues with the fabric achieving uniformity of color in case of certain critical dyes like turquoise. One advantage is that the machine is simple to operate and very low on capital as well as working expenditure. 3. Padding mangle. This is the mostly used machine today owing to the fact that it is a continuous machine and hence offers a higher productivity. But again, it has a higher capital as well as working expenditure, making it unsuitable for small-scale operators. In this method, the fabric is passed through several rolls that make it go through a solution of the dye along with certain accessories in the first step, and then a series of other steps. What are the following steps? The first one to follow is a hot chamber that has hot air at a particular temperature blowing through. This heating chamber helps in making the dye react with the fiber chemically, or penetrate inside physically, as the case may be. A set of press rolls ensure that the excess of dyes and accessories picked up from the padding mangle have been washed off the cloth even before it enters this heating chamber. After this heating chamber, there are a series of washes, some of them with only soft water and others with soap solutions to remove the excess of dyes and accessory chemicals that may still be left on the dyed cloth, thereby improving fastness. 4. Beam dyeing. This has an extensive use in yarn dyeing, but in case of fabric dyeing too, it can be resorted to. Take a fabric and wound it up on a perforated beam, place the beam inside a closed chamber and pass the liquor containing dyes and accessory chemicals through the beam such that the liquor flows from inside to outside. In the process, it will penetrate the fabric wound around the beam under pressure, thereby dyeing the same. Since there is involvement of tension here, delicate fabrics cannot be dyed. However, high temperature and pressure can be achieved as the dyeing occurs in a closed chamber. This process is also classified as a batch process and it ranks in between padding mangle and jigger in terms of efficiency and volume of fabric handled per unit time.